Unit 2, Formative 1, Day 1, Day 4, Compound Inequalities. Okay, so compound inequalities deal with and inequalities and or inequalities. Okay, the difference is when you have an and inequality, it means it has to be both. For instance, if you have -3 and 6, okay, you could say that x is greater than -3 and less than 6. Okay, so if you have an and inequality, your graph is going to look like this, where the graphs go together. Okay, they go towards each other because x is both greater than -3 and it's less than 6, excuse me. Okay, or you could have the or inequalities where it's either one or the other. So keep that same example. So you have your -3 and your 6. In this case, x would be less than -3 or greater than 6. No number can be both less than -3 and greater than 6. Okay, so that is what we call an or inequality when your graphs go out. Okay, so let's try solving some of these. We're going to start with the ors. Okay, so number 1 says solving graph. You have 2x plus 4 is greater than 10 or 3x minus 1 is less than -7. Now when you solve these, you solve them the exact same way you were solving. So we're just going to ignore the right side right now and we're going to focus just right here on this one. Okay, so if I was to solve that one, what I would do, I could put my line down here. I would subtract 4 from both sides. So you have 2x is greater than 6. Okay, and then I would divide both sides by 2. So x is now, we divided by a positive number, so I don't need to flip the sign. So x is greater than 3. Okay, so that's one of them. Now we're going to solve the other one. Okay, again, put my line down here. You could add 2 to both sides. Oh, excuse me, add 1. I don't know why I put 2. Add 1 to both sides. So let's cancel. You have 3x is less than -6. Divide both sides by 3. Again, we divided by a positive, not a negative. Okay, so we get x is less than -2. We only flip the sign when we divide by a positive, or when we divide by a negative. Okay, so my answer is x is greater than 3 or x is less than -2. So I graphed those on the number line. Now we know -2 has to be to the left of 3 because -2 is smaller than 3. Okay, at -2 it's an open circle and x is less than -2, so we shade left. Okay, for the other one it's an open circle as well because it's not equal to. X is greater than 3, so we shade to the right. So that is an or graph because x is either less than -2 or it's greater than 3. It can't be both. Let's try another one. Solving graph number 2, -4x minus 8 is greater than or equal to 16, or 2x minus 3 is greater than 7. Okay, so we could add 8 to both sides. So you get -4x is greater than or equal to 24. Divide both sides by -4. So you get x is less than or equal to -6. Okay, or on this side, we could add 3 to both sides. Oh, let's go back to this first one, right here. I had to flip that sign because I divided by a negative. So when I divide by a negative, I changed it to a less than or equal to sign. Alright, so back to this one. These are gone. You have 2x is greater than 10. Okay, so 2x is greater than 10. Divide both sides by 2. So you get x is greater than 5. Okay, so your answer is x is less than or equal to -6 or x is greater than 5. Well, between -6 and 5, -6 is on the left. 5 is on the right. Okay, at -6 you look and you see that there's a line right there. Okay, so that means we have to put a closed circle, so we have to shade it in. And x is less than -6, so we shade to the left. Over here, if you look, you have no line underneath of that, so it's just greater than sign. So you have an open circle, and you shade to the right. So your answer is x is less than or equal to -6, or x is greater than 5. Alright, let's do some and. Solving graph, -6 is less than or equal to 5x plus 4, which is less than 29. Okay, as you can see, x is in the middle, so what I do is I put my line down both sides. Here's the thing that we're going to mess up on these. When you do something to the middle, you have to do it to both sides. Okay, when I start with 2 signs in my problem, I have to finish with 2 signs in both problems. I do not want to do anything with that -6. Okay, some people try to add that to the other side. We don't want to do that. We want to keep all 3 separate. Okay, so I want to subtract 4, and if I do that from the middle, I have to do it to the right side and the left side. Okay, it has to do it to all 3, otherwise you're going to mess up. So -6 minus 4 is -10. I did not multiply or divide by a negative, so I keep the sign the same. In the middle, all I'm left with is 5x, which is less than 25. Okay, now again, I still want to get x by itself, so I divide the middle by 5. Well, if I do that, I have to do it to the right side and the left side. -10 divided by 5 is -2, which is less than or equal to x, which is less than 5. Okay, so if you look, x is between -2 and 5. You could read this backwards, and you could say right here that x is greater than or equal to -2 and less than 5. Okay, so when you graph this, you have your -2, you have your 5. Okay, because of that line underneath, it's equal to -2. So you shade that one in. The other side is open because there's no line. Okay, and x is between them, so I shade in between. Okay, let's try one more. Solve and graph. 16 is greater than -2x plus 6, which is greater than or equal to -12. So again, I can put my lines down here. I want to get x by itself, so I need to move things away from the middle. Okay, so I need to subtract this 6, but if I do it to the middle, I have to do it to the right side and to the left side. Okay, so 16 minus 6 is 10. Do not need to flip the sign because I did not multiply or divide by a negative. We get -2x in the middle. Again, don't need to flip that sign. You get -18 on this side. Now x is still not by itself, so I need to divide everything by -2 to all 3, not just the middle, not just the right side. Okay, we were dividing by a negative, which means I need to flip my sign. So 10 divided by -2 is -5. I'm going to change that greater than sign to a less than sign because I divided by a negative. So you have x, you have less than or equal to +9. Okay, x is by itself. If you look, x is between -5 and 9, or x is greater than -5 and less than or equal to 9. So I put my -5, I put my 9. It does not equal -5, so it's an open. It does equal 9, so it's closed, and we shade in between. Okay, so that's compound inequalities. You have or compound inequalities, and you have and compound inequalities, so you need to be able to do both and graph both. All right, we'll see you tomorrow.